Right, guys, how are you? Right, we're back. For the guys who are on my channel, you know that you might notice that I changed the thumbnails for some of the videos. Yeah, it's just some housekeeping, but that doesn't matter. What matters is the topic. And today we are looking at Mendel's law of segregation. But before we go there, let's just do a recap of where we are and where we are going. Where are my exam guidelines? Where are you? I can find you. Right. We have looked. We have worked with the exam guidelines. Where am I? 2015 open, and then where am I? 2017. Right. This is my 2017. Right. So we have done this part. Differentiation of these terms. Our brother Mendel, we're still looking at him. We're still mentioning him. And then today we're going to be doing is Mendel's principle of segregation. That's what we're looking at today. Mendel's principle of segregation. Right. Now we don't know what our 2017 exam guidelines want us to do. So they don't know if they want us to dance with him as we look at this principle of segregation. We don't know if they want, I don't know what they want. But for us to get an idea of what they require from us, the 2015 guidelines are clear. What are they saying? State Mendel's principle of segregation. So we shall state it, and then we shall look at the format for representing genetic crosses, solving monohybrid genetic problems. Why are we doing that? Because it's covered in the 2017 guidelines. So we'll look at this. Right, all this stuff is following under monohybrid crosses. Right. You know me, I like to start by recapping the previous lesson. And in the previous lesson, we talked about multiple alleles and polygenic characteristics. So we now know that multiple alleles are a situation where a gene has more than two possible alleles, like your blood types, and then which, like for human blood groups, you have the gene that codes for your blood type is actually it's got three different alleles. But obviously, at any given time, every human being has got two. You can't have the three within your system. You can only have the two. Why? Because one allele is coming from your father, the other allele is coming from your mother. And then we looked at polygenic characteristics. And we say that polygenic characteristics are hereditary characteristics that are controlled by more than one gene pair at different loci. And then we looked at characteristics that are polygenic in human beings like height, skin complexion, weight, and all this. And then we agreed that no, you see, when you have polygenic characteristics, when you look at usual characteristics, if you're looking at your simple pea plant, you got two things that you have to look at. You got, like for every characteristic, there are two things, you know. So if you're looking for a flower color, you're gonna have purple flowers and white flowers. And then if you're looking at pot color, you got green pot color and yellow pods, right? But then with polygenic characteristics, because they have so many genes that come together in a mixture and then they give us a particular phenotypic characteristic. That means that because there are many genes that are involved, then you're going to end up with a range of phenotypes. As a matter of fact, it is a series of phenotypes that usually occur what? Over a continuous spectrum ranging from one extreme to another. And then we say that this is called continuous variation. So for example, we talked about, what did we talk about? We talked about, where's my pen? Right. We talked about skin complexion. And then we say that on one extreme, as you move into in a population, as you move into a population, then you're going to start with one extreme to another extreme. What does this mean? On this side here, if you look at skin complexion, you got dark, nightshade, grayish dark, black, 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 black. And then gradually the complexion gets lighter. And then on the other extreme here, you have translucent shamas. Costly white, you know. And then the majority of the population is found somewhere in here. And then the same thing occurs with height. You got colors, short. And then that side there, you got extra long. Two extremes, and the majority of the population is found within this side. On the y-axis, that's where you have your particular characteristic. So if you're looking at height, you have your height there, meters, from very short to very tall. Then if you look at shoe size, same thing. Very, very small shoe sizes, and then across the board as you go up, then you end up with very, very big shoe sizes. Right. That's the end of us talking about multiple alleles and polygenic characteristics. Now let's go to Mr. Mendel again. Where are you? Let's blow this up. What are we looking at? Meiosis and the separation of what? Of alleles, which is basically Mendel's law of segregation. Right. What did we learn from our exam guidelines? 2017 says Mendel's principle of segregation. We don't know. We don't know. We need a clue. Do they want us to describe it? What do they want? 2015 ones they tell us. State. So you go to your exam guidelines, the 2017 guidelines, and then you just put the thing here. Where are you? I'm looking for my pen. Right. There we go. So we go and then we write state in our exam guidelines. Are we together? So we need to state Mendel's principle of segregation, and it actually comes as a past exam paper. As a past exam question, sorry. Right, what does Mendel's principle of segregation say? There we are. Bingo. Right. During meiosis, I hope you can see that. I hope you can see that. During meiosis, a homologous chromosome pairs, during meiosis, homologous chromosome pairs that carry pairs of alleles to control hereditary characteristics separate from each other, and thus each gamete produced receives only one allele of a gene pair. And this is known as Mendel's law of segregation. We need to state this. State is a fancy way of saying creme. So please make sure that you got it on point, and then you are good to go with it. Walk with me. During meiosis, homologous chromosome pairs that carry pairs of alleles to control hereditary characteristics separate from each other. So, homologous chromosome pairs are what? Are separating. And every time when they are separating, homologous chromosome pairs separate from each other. And every time when the two are separating from each other, what are they separating also? They are separating pairs of alleles that control hereditary characteristics. And because of this separation of homologous chromosome pairs, we're talking about what? We're talking about meiosis. That should be term 1. Because they are separating, and the homologous chromosome pairs, my two fingers of homologous chromosome pairs, they are separated during what? During meiosis. And every time when they are separating on each chromosome, we are having alleles that control particular hereditary characteristics. So if the two chromosomes on one homologous chromosome pair are separating, it means that even the alleles that are carrying the gene pair for a particular characteristic are going to separate. And every time when they separate and go into a new gamete produced. That new gamete that is produced is going to carry only one allele of a gene pair. If you didn't get that, I advise you to rewind. Because you need to get this for us to know where we're going. So during meiosis, homologous chromosome pairs homologous chromosome pairs are going to separate. And when they separate, they're also going to be carrying what? Alleles. So it means that on a gene pair, the gene pair is going to be split, as the two alleles are going to different with different chromosomes. Now, when this happens, it means that each gamete that is produced receives only one allele of a gene pair, and this is known as Mendel's law of segregation. Segregation is a fancy way of saying separation. So basically, that's Mendel's law of segregation. I hope you got that. Right. Walk with me. Let's go back to our lovely and favorite pea plant. Let's look at the characteristic of height. Why do I always go back to height? I don't know. But anyway, today let's do height and then we'll do another one also. Are we together? We need, for you to know what we're doing here, you need to know your meiosis. Let's recap your meiosis. But this is not a meiosis lesson. Right. In meiosis, to keep it nice and simple for you, we know that there are two phases of meiosis. We know that you have a cell. And cell undergoes meiosis 1 and gives us two cells. And the two cells undergo meiosis 2 and give us, this cell will give us two cells, and then this cell will give us another two cells. That's what we know. That's a basic summary of what meiosis is. So each cell gives us 4 daughter cells. Right. Walk with me. Remember, we used to talk about how each chromosome, each cell, has got, it goes from diploid to haploid and not all. So basically, if you start with chromosomes in here, if you start with 4 chromosomes, by the end of meiosis 1, there will be 2 in there, 2 in there. And then again, by the end of meiosis 2, you are also going to have what? 2, 2, 2, 2. Right. Walk with me. I want us to look at a karyotype and pretend that it is that of a pea plant. Where is my karyotype? There we go. I said let's just pretend. It's not, it's a human karyotype. But let's just pretend. Let's agree to pretend that on a homologous chromosome pair, where are you? I need some red in here. Bingo. Let's just pretend that this karyotype is of a pea plant. And let's just pretend that the chromosome pair, the homologous chromosome pair, that codes for height in people is chromosome pair number 3 in the karyotype of a pea plant. Let's just also agree that these locus, oh gosh, my thing is a bit shaky, is where you find the alleles. Right, I hope you get that. We're pretending right now. Right. So if you find an homologous chromosome pair, the gene that codes for height in pea plants, and then on this particular locus here, that is where you're finding the alleles that make up the gene pair. So you have capital letter T and capital letter T. Right. If you have these two, let's say that this one is small letter T. So basically, you are basically saying that you have your homologous chromosome pair number 3. This is your 2. I'm simplifying it for you so that you understand. And then here, you got a thick one. Why? Because it is the dominant. And then here, you got the small one, which is the recessive. That is chromosome pair 3. This means that if you look at chromosome pair 3, carrying these alleles for height in pea plants, it means that according to Mendel's law of segregation, it means that during meiosis, the homologous chromosome pairs, which homologous chromosome pair? This one, chromosome pair 3, is going to what? Is going to, and this homologous chromosome pair that carry pairs of alleles controlling what? The characteristic of height in pea plants will separate during what? During meiosis. These homologous chromosome pairs are going to separate, and thus each gamete that is produced will only receive one allele of that gene pair. In other words, to make it nice and simple for you, we are saying that in Mendel's law of segregation, every time when what? When meiosis occurs, each homologous chromosome pair, and bear in mind that each chromosome of that pair is carrying alleles, and during meiosis, each homologous chromosome pair is going to split. Who split? During meiosis. Who split? During meiosis. Who split? During meiosis. And each gamete is only going to receive one chromosome of a homologous chromosome pair. If it is only receiving one chromosome of a homologous chromosome pair, each gamete, it also means that it is only receiving one allele of a potential gene pair. Each gamete. That is why you see in sexually reproducing organisms, you're going to need another partner to come, because your gametes are only giving one pair of a homologous chromosome pair. And the other person that will come, that you will reproduce with, will bring the other set, so that it goes back to having a homologous chromosome pair for each characteristic, for each set somatic cell. Sorry, not characteristic. Right. Now listen to this. Look at me. Hope you can see me. Right. I have genes that are found on my chromosomes. Are we together? Now listen to this. If you look at any part of my body except for my corners, if you look at any part of my body, let's pick up here. The cells that are here, if you look at the karyotype, It consists of half a pair from my mom, half a pair from my father. Of course, there was crossing over that occurred, which made me to be unique in some aspects. That made me different from both mom and dad. In some aspects, I am similar to my father. In some aspects, I'm similar to what? To my mom. But at the end of the day, the DNA that is within my somatic body cells is coming from half from my mom and half from my father. Only when I reached puberty, when gametogenesis, meiosis, starts occurring in my testes. Why? To split those homologous chromosome pairs that are found where? On my somatic cells. And every time they are being split, these homologous chromosome pairs, what is happening? The alleles that are making gene pairs are also going to be split. So as a homologous chromosome pair is being split, each chromosome is going to go into another gamete, and each chromosome will carry its own alleles up until each gamete is only half the chromosome number and also half the alleles that make up a gene pair. I hope you got that. Right. Walk with me. So, to make this nice and simple for you, give me a second. I'm having a problem with my body. So, it gets a bit tricky. So please bear with me. Let me just align it and see if we can make some magic happen. Right. Should be fine now. There we go. Now, I hope you're with me. Now, if you are looking at the height in P plants, so our key, what does it say? Our key says for alleles, the allele T will code for what? For 12 P plants. And the allele that will code for what? For short. P plants. I hope you get it. Right. Shall we? Can you please come with me to this party? Can we take right? We agree that here you have that, and then here you have small letter t. Can we take only this and look at this pair during meiosis? Yes, we know that during meiosis you're going to have all the homologous chromosome pairs being split. But now we're only going to look at that one homologous chromosome pair to see what happens with it. Can you walk with me? Right. Where are you? If we walk with this thing, what is the genotype that we're given? That's our genotype. Right. So we know that your cell at the beginning is a job. Right. A cell at the beginning has this. Remember, we're only focusing on that gene pair. So let's just say that this is, make it big here to show its dominance. And then this is the recessive. And then it's going to undergo what? It's going to undergo DNA replication. Such that this one stranded with sister chromatids, and that one will also appear as double stranded with sister chromatids. This is what? DNA replication. I hope you get that. Right. Walk with me. How many chromosomes are we having? We are having 2 chromosomes. 1, 2. How many pairs of a homologous chromosome are we having? We are only having 1. Right. DNA replication occurs. We still have 2 chromosomes. Chromosome 1 pair. Chromosome 1 and chromosome 2. How many homologous chromosome pairs do we have? We still have 1 homologous chromosome pair, because this is a pair. Only difference between this pair and that pair is that for this pair, this is after what? DNA replication, right? When this happens, and then we know that during meiosis 1, I hope you're with me. During meiosis 1, this cell is going to be split into 2 cells. At the end of meiosis 1, you are going to have 2 cells that have what? That have haploid chromosomes. They have half the chromosome number. Right. Assuming that I said assuming. Let me repeat that. I said assuming. I'm just doing it for simplicity's sake. Assuming that there is no crossing over that occurs. Let's just assume that there's no crossing over that occurs. How many chromosomes did you study? 2. How many homologous chromosome pairs? 1. How many chromosomes did you start with? 2. Before what? Meiosis. DNA replication occurred. And when it occurred, how many chromosomes did you end up with? 2. The only difference is that these 2, each is made up of identical units called sister chromatids. So this one here that is carrying the allele for dominant, for top, this chromosome here ends up with a sister that is also carrying for top. This one here, this chromosome carrying the recessive for short, replicates and ends up becoming the same chromosome, but this time with an identical unit, sister chromatid. And this is a chromosome. This is a chromosome. But the only difference is that they are now carrying sister chromatids of each other. And these are attached way together at the central main. That's a free meiosis revision for you. Hope you go back and revise if you're getting lost. Right. Walk with me. At the end of meiosis 1, we know this from term 1 that in meiosis 1, at the end of meiosis 1, the chromosome number is halved. So, how many chromosomes did you start with? 2. How many chromosomes do we have here? 2. And we know at the end of meiosis 1, we're going to have half the original that we started with. So if we started with 2, it means that each cell at the end of meiosis 1 should have 1 chromosome. Absorb that. Right. So if these 2 chromosomes of 1 homologous chromosome pair undergo DNA replication, and then you end up with again the same 2 chromosomes of a homologous chromosome pair. But this time, each chromosome has a sister chromatid. At the end of meiosis 1, it means that, assuming no crossing over occurred, then it means that this chromosome is going to end up in here. And then this chromosome is going to end up in here. That's the end of meiosis 1. 2 cells formed, and the 2 cells are diploid cells. And then we know that at the end of meiosis 2, the sister chromosomes will now split at the centromere and form daughter chromosomes. The chromatids, sorry, not sister chromatids. The chromatids will now split at the end of what? Meiosis 2. Again, this one here will give us 2 cells. This cell will give us its own 2 cells. But because these are splitting at the centromere, then you end up in one gamete. And then this one will end up in this one. This one will end up in this one. And this one will end up in this one. And ladies and gentlemen, this is how Mendel's law of segregation occurs. That during what? Meiosis, the homologous chromosome pairs that are carrying the alleles for a specific trait will separate, and as they separate, the result is that each gamete only carries one of an allele pair. I hope you got that. I hope you got that. Right, I need to make this nice and sweet and short for you. Right, check this one out. This diagram, I didn't want to show you at the very beginning because I need you to get a hang of it. I want you to go and do, here's some homework for you. Go and do, or draw a diagram of showing the application of Mendel's law of segregation for flower color. Yes, for flower color. Go and do a diagram showing the segregation, Mendel's law of segregation for flower color. If you have any problems, you know where to find me. Right. But let's go back to my diagram. There we go. In this one here, they're using what? Seed shape. Remember in seed shape you got round seeds, which are the dominant ones, and wrinkled seeds, which are the recessive ones. So, in a parent that is heterozygous, what is the phenotype for this parent? Round seeds. You have your homologous chromosome pair carrying the 2 alleles of a gene pair for seed shape. And before meiosis starts, what happens? DNA replication. So this one here replicates to end up with two identical strands joined at the centromere. Same for the other one, joined at the centromere. And then meiosis 1 occurs, assuming for us to simplify it, to make it very simple for you. Assuming that there is no what? There is no crossing over. Then this chromosome will end up in its own cell at the end of what? Meiosis 1. And this one will end up in this one at the end of meiosis 1. So what did we study? We started with 2N, diploid, and we just immediately went to what? To haploid. So this is the end of meiosis 1, and we have half the chromosome number. And at the end of meiosis 2, you're going to have 4 gametes. This one here will split into 2, 1, 2. And then you end up with this one coming in here, this one coming in there. Same thing here. This one will come here, and this one will come in. And then that's it. Right. I hope you got that. Right. Just a brief recap, so that we don't get lost. Somatic cells, your body cells, have homologous chromosome pairs and are what? Diploid. And each homologous chromosome pair carries what? 2 alleles for a gene pair. For gametes, remember you only start making gametes when you're in puberty. Because they are gametes, if it is me, it is my sperm. If it is a female, it is her ovum. For gametes, there are no homologous chromosome pairs. And gametes are also what? Haploid. Because remember, there are cells that have undergone what? Meiosis. And then because they are haploids, they only carry 1 pair of one allele for every gene pair. So what is Mendel's law of segregation again? During meiosis, homologous chromosome pairs that carry pairs of alleles to control hereditary characteristics separate from each other, and thus each gamete produced receives only 1 allele of a gene pair. And this is Mendel's law of segregation. I hope you enjoyed yourself. You know where to put the comments, you know where to take it up. Bye. Take care of yourselves, guys.